The test is this evening, starts at 5 till 7. It's about 90-minute test. So make sure you finish writing by 6:30, and then you have 30 minutes to upload. If you do not submit, again, that counts as if you did not write the test. So make sure you know how to scan. I think we gave you enough time to practice with submitting using the practice test. By now, I think you should be comfortable submitting on time. So we will not accept any excuses, will not mark anything that is sent via email. Everything must be done on e-learning. So today, let us finish off this chapter. Okay, it's not too much to do, just a lot of exercises that we will go through so that you are comfortable with this chapter. And then on Monday, we can start with something else. Now, we are continuing with simultaneous equations using substitution to solve them. Now, you get questions like this. You have x minus 2y. This is equal to 8. And xy, this is equal to 24. Now this one you cannot solve by elimination because the second equation, xy equal to 24, is not linear. So when you have one being linear and the other not linear, what you need to do is make x the subject of one of them, and then, sorry, not x, you can make x, but it's not restricted to x. You make x or y the subject of the formula in one of the equations, and then you substitute it into the other equation. You solve for y, and then you get back and solve for x. So here we have equation 1. We have equation 2. Okay, everybody's muted now. Let us continue. Right, so from equation 1, I will rewrite equation 1 as x is equal to 8 plus 2y. So then this new equation that I get, I will substitute it into the other equation. So wherever I have x, I will then put x plus 2y. So I have 8 plus 2y times y, and this is equal to 24. And you know how to multiply out the brackets. I have 8y plus 2y squared, and this is equal to 24. Okay, hold on just a minute. Okay, so this is now a quadratic equation. We should be able to solve it. We write everything on one side, 0 on the other side. So you have 2y squared plus 8y minus 24. This is equal to 0. Now all the coefficients are divisible by 2, so I can divide by 2. So I have y squared plus 4y minus 12. And this is equal to 0. And then we try and factorize it. We look for two numbers that when you multiply it, the answer is negative 12, and when you add them, the answer is positive 4. Those two numbers are negative 2 and positive 6. So y minus 2, y plus 6, and this is equal to 0. So when I solve this, I'll get y is equal to 2, or y is equal to negative 6. Then when y is equal to 2, this means that x is equal to 12. Okay, so I substitute back into this original equation here. So I say 8 plus 2 times 2, then I will get 12. And then here, this means that x is equal to negative 4, sorry. Right, so I can write this down, the solutions. Are 12, 2. Remember, it's x, y. X must come before y. And negative 4, negative 6. And as usual, it is very important that you check the solutions. Always check and see that the solutions you got are correct. And then now exercise 4.4.2, we have x minus y, this is equal to 1, and then xy, this is equal to 12. So again, you make x or y the subject of the formula in one of them, then substitute in the other one. The one you choose to make the subject of the formula is up to you, and it doesn't even matter. But always pick the one that is easier to make the subject of the formula. So from this one, I can get x is equal to 1 plus y. Then this x, I will replace it with what I have over there, and then I will solve for y, then come back and solve for x. So I have 1 plus y times y, this is equal to 12. And you know how to multiply out the brackets. I have y plus y squared, this is equal to 12. And I rewrite this, this is 12y, sorry, y squared plus y minus 12, and this is equal to 0. So I look for two numbers that when I multiply them, the answer is negative 12, and when I add them, the answer is positive 1. So the numbers are positive 4 and negative 3. So I open my brackets, and I put my variable, my two numbers, like that. So this means that y plus 4 is equal to 0, which means that y is equal to minus 4, and y minus 3 is equal to 0, which means that y is equal to 3. Then now I go back and solve for x. So when y is equal to negative 4, I say that x is equal to y plus 1, or 1 plus y. Okay, so this is negative 3. So the first solution will be negative 3, negative 4. And then when y is equal to 3, we say that x is equal to 1 plus y, which is 4. So the second solution is 4, 3. So these are my two solutions here. And again, always check your solutions, substitute them into the first equation, then into the second equation, and see if they satisfy both of them. Okay, so here, this time we have linear and we have a quadratic equation. So from this first equation, I can make x the subject of the formula. So I will have x is equal to 2 plus y. And then this x over here, I will come and substitute it there. And then I will have one equation only in terms of y. And that's easy to solve. So I have 2. X is 2 plus y squared minus 3 times y squared, and this is equal to 15. Now remember, 2 plus y squared, I'll do it over here. 2 plus y squared, this means 2 plus y times 2 plus y. You see sometimes students write this squared, they put a minus over there. That is not what squared means. It must be the same bracket multiplying by itself. That's what squared means. Then you multiply the friends greeting each other. That's how you'll greet each other. And then you will get 4 plus 2y plus 2y plus y squared. And then when you simplify it over here, you will have 2. You have y squared plus 4y plus 4. Okay, so I've simplified this one that I have over there. Then minus 3y squared is equal to 15. And notice I've left it in brackets because the 2 must multiply the entire product, not just the y squared that comes first. Then you multiply out your brackets. You have 2y squared plus 8y plus 8 minus 3y squared. And this is equal to 15. Then collect your like terms. I see I have y squared and I have y squared over there. So that should give me negative. So I have negative y squared plus 8y plus 8. And this is equal to 15. So again, quadratic equation, we like everything on one side, 0 on the other side, and we like the coefficient of the y squared to be positive. So I'll bring everything to this side over here. So when I do that, I have y squared minus 8y, and then when I subtract 8 on both sides, I will end up with positive 7. This is equal to 0 because 15 minus 8 is equal to 7. And then ask, can this be factorized? We look for two numbers. When you multiply them, the answer is 7. When you add them, the answer is negative 8. So those two numbers are negative 7 and negative 1. So we open our brackets. We put our variable, then our two numbers, negative 7 and negative 1. So this first bracket is 0, which means that y is equal to 7. Or the second bracket is equal to 0, which means that y is equal to 1. Then we have to go back and solve for x. Remember, they are a pair, so when you write your solutions, I need to see a pair. So here, when y is equal to 7, we know that x is equal to 2 plus y. So this is 2 plus 7. This is equal to 9. So the first solution is 9, 7. Remember, it's x, y. X must come first. 7, 9 is not the same as 9. So remember this. This is not equal to 7, 9. And this is wrong. Do not write it like that. Okay, and then when y is equal to 1, we have x equal to 2 plus 1. This is equal to 3. So the second solution is 3, 1. So there I have my two solutions. So this is the first one, and then that is the next one. We have 3x squared minus y squared. This is equal to 3. And then we have 2x minus y is equal to 1. So looking at this equation, it's easier to make y the subject of the formula. So I will have y is equal to 2x minus 1. And then this 2x minus 1, I'm going to substitute it over there. Everything else will stay the way that it is. So when I substitute it, I have 3x squared. The minus will remain there. Then I just replace the y with 2x minus 1. The squared should still be there, and this is equal to 3. So this one here, again, I need to multiply it the way we did. I'll just show my working over here. So I have 2x minus 1 times 2x minus 1. You multiply the bracket by 2x times 2x, I get 4x squared. 2x times minus 1, this is minus 2x. minus 1 times 2x, this is minus 2x, minus 1 times minus 1 is positive, and this is just 4x squared minus 4x plus 1. So that is what this bracket here is equal to. So now I write it. So I have 3x squared minus, and now I keep it in a bracket because this negative there is multiplying. It's negative 1 of the entire bracket. So I have 4x squared minus 4x plus 1, this is equal to 3. So this negative 1 here will multiply inside the bracket like that. So when I do that, I have 3x squared minus 4x squared plus 4x minus 1, this is equal to 3. Then I have x squared and x squared over there. This leaves me with negative x squared plus 4x minus 1. This is equal to 3. Then I bring everything to one side, 0 on the other side. I'll have x squared minus 4x minus 4, no, plus 4. This is equal to 0. So I add x squared on both sides. I subtract 4x on both sides, and then I add 1 on both sides. In this one, you can factorize it. You look for two numbers. When you multiply them, the answer is positive 4. When you add them, the answer is negative 4. Those two numbers are negative 2 and negative 2. So you have x minus 2 times x minus 2. This is equal to 0. So this is just x minus 2 squared is equal to 0 because this is multiplying by itself. So that is what squared means. You can take the square root on both sides. You have x minus 2 is equal to 0. This means that x is equal to 2. Now we need to solve for y. Y, we said, is equal to 2x minus 1. So this is 2 times 2 minus 1. This is equal to 3. So here I have only one solution. So this is 2, 3. Okay, so, or you can say it's two solutions, but it's repeated. Just like when we solve a quadratic equation and it's repeated, the same thing is true over here. So this one here is our only solution. And number 7, we have x squared minus xy. This is equal to 14, and y is equal to 3 minus x. Now this one is very nice because y is already the subject of the formula. So all we have to do is take this y here and we'll substitute it over there. So when I do that, I have x squared minus x times 3 minus x. This should be equal to 14. Then again, the x will multiply inside like that. We'll have x squared minus 3x, then plus, because negative and negative make plus, x squared. This is equal to 14. I have 1x squared plus another one. This gives me 2x squared minus 3x. This is equal to 14. And I want everything on one side, so I subtract 14 on both sides. So I have 2x squared minus 3x minus 14. This is equal to 0. So this one, you look for two numbers. If you multiply them, the answer is 28. And when you add them, the negative 28, when you add them, the answer is negative 3. So that is 7 and 4. Negative 7 and positive 4. So again, you open your brackets. You put your variable, the two numbers, we say it's negative 7 and positive 4, and then you divide by the coefficient of x squared. Okay. Right, so you divide by 2, simplify your fractions as far as possible, and then take the denominator to the x if necessary. So this is 2x minus 7, because 7 over 2 is in its simplest form. and then I have x plus 2. This is equal to 0. So this means that 2x minus 7 is equal to 0, and therefore x is equal to 7 over 2, or x plus 2 is equal to 0, which means that x is equal to minus 2. So I have two values of x. I need to work out the values of y. So when x is equal to 7 over 2, remember the formula for y, it's over here. We have 3 minus x. So y will be 3 minus 7 over 2. 7 over 2 is 3.5. So 3 minus 3.5, this is negative a half. So my first solution is 7 over 2 and then minus a half. Then the second one, when x is equal to minus 2, y is equal to 3 minus negative 2, and this is equal to 5. So the second solution is negative 2 and 5. So as usual, always check your solutions, make sure that they are correct, substitute them into the original equation and see if you did it correctly. And number 9, we have y is equal to 4x squared, and then we have y plus 2x. This is equal to 2. Now here, y is already the subject of the formula, so I will substitute it over there, and what I get is 4x squared plus 2x. This is equal to 2. I bring everything to one side by subtracting 2 on both sides, so I have 4x squared plus 2x minus 2. This is equal to 0. Then I see that 2 is a common factor with all my coefficients, so I divide by 2. I have 2x squared plus x minus 1. This is equal to 0. Then I look for two numbers that when I multiply them, the answer is negative 2. So I say this 2 times that negative 1, that gives me negative 2. And when I add the two numbers, the answer I get should be positive 1. So the two numbers are 2 and negative 1. So I have my variable, then I put numbers positive 2 and negative 1, then I divide by the coefficient over there, so this is over 2. Then simplify as far as possible. This is just x plus 1, and then here I have 2x minus 1, and this is equal to 0. So the first bracket equal to 0. This means that x is equal to minus 1, and then 2x minus 1 is equal to 0. This means that x is equal to a half. Okay, then we solve for y. So when x is equal to minus 1, we know that y is equal to 4 times x squared. So 4 minus 1 squared. This is just equal to 4. So the first solution is minus 1, comma 4. And then the second one, when x is equal to a half, y is equal to 4 times a half squared, and this is equal to 1. So the second solution is half, comma 1. Right, and then I'm done with that. Number 11, we have 3xy minus x. This is equal to 0. And then x plus 3y. This is equal to 2. So it's easier to make x the subject of the formula with this equation over here. So I rewrite it as x is equal to 2 minus 3y. And everywhere I have x over here, I'm going to substitute 2 minus 3y. And then over here, I'm going to substitute 2 minus 3y. So what I have is 3, 2 minus 3y, and then the y, this one, it should still be there. Then minus 2 minus 3y. So I keep it in brackets to show that I'm subtracting the whole of 2 minus 3y, not just the 2. Then multiply out the brackets, or what you can do is first multiply the 3 and the y and then multiply it inside the brackets, because multiplication is commutative. The order you do it in doesn't really matter. So if I multiply the 3 in first, I have 6 minus 9y. The y is still there. Then minus, now this minus 1 can multiply in. So I have minus 2 plus 3y. This is equal to 0 because negative and negative over there gives me a positive. Then the y should also multiply. I have 6y minus 9y squared minus 2 plus 3y. This is equal to 0. Okay, so I have a quadratic equation. Let's simplify 9y squared, and then this is 6y, 3y. This adds up to 9y minus 2, which is equal to 0. So I always like my coefficient of y squared to be positive, so I can divide everything by negative 1. So I have 9y squared minus 9y plus 2. This is equal to 0. So you factorize this. You look for two numbers that when you multiply them, the answer is 18. So I see this 9 times the 2. And when you add them, the answer is negative 9. So those two numbers are negative 6 and negative 3. So we open our brackets. I put my y. Then the two numbers, negative 6, negative 3. Then I divide by 9. I divide by 9. Then I simplify the fractions as far as possible before I take the 9 over. So this is y minus 2 over 3. Y minus 1 over 3. This is 0. And then I have 3y minus 2. 3y minus 1. This is equal to 0. So now it's factorized. So it means 3y minus 2 is equal to 0. And if 3y minus 2 is equal to 0, this means that y is equal to 2 over 3. And if 3y minus 1 is equal to 0, this means that y is equal to 1 over 3. Now I need to solve for x as well. The equation for x was 2 minus 3y. So when y is equal to 2 over 3, I have x is equal to 2 minus 3 times 2 over 3, and this gives me 0. So the first solution is 0 and 2 over 3. And then when y is equal to 1 over 3, I have x is equal to 2 minus 3 times 1 over 3. 3 times 1 over 3 is equal to 1. 2 minus 1 is just equal to 1. So my second solution is 1 and 1 over 3. Did I write the first one correctly? Yes, I did. So x must come first and then y. It's always in that order. And then these are your two solutions. As usual, check and make sure that they are indeed correct. You substitute them into the first equation, substitute them into the second equation, and see if the values do satisfy the equation. Do we have any questions on that? Are we fine? Okay, if everybody is fine, then we can move on to the last part of this chapter. So we have exercise 4.5. Now exercise 4.5, these are logarithmic and exponential functions that are a little bit more advanced, but not really, because we've done equations like this before, so there shouldn't be any problems. So like with the previous exercise, I will do the odd numbered questions and then you can try the even numbered questions. Then you can always tell if your answer is correct or not by substituting. That's why I always say check your solutions, then you know if you're correct or not. Exercise 4.5. With the first one, we have log of x minus 3. Minus 3 is equal to 0. So we are told to do this without a calculator. So we shouldn't end up with any decimals or anything like that. So the first thing we do here is we make the logarithm the subject of the formula. So we have log x minus 3. This is equal to 0. This means that, sorry, this is not equal to 0. It is equal to 3. I add 3 on both sides. So here the base of my logarithm is 10 if it is not written. So this means that base to the power of the exponent, this is equal to the argument. And then when I solve for x, I get x is equal to 10 to the power of 3 plus 3. Now 10 to the power of 3 is 1,000. You can do that without a calculator. And this is just equal to 1,003. And that is your solution. Number 3, we have log base 5 of x minus log base 5 of x plus 4. This is equal to minus 2. So you need to remember your laws of logarithms, and since today is the test, I'm sure you guys all know your laws. Here the bases are the same. I have base 5 here and base 5 there. Those are the same. And if I'm subtracting logarithms that have the same base, I will just divide the arguments. So what I have is log base 5 of x divided by x plus 4. And this is equal to negative 2. Okay, then I can rewrite this in exponential form. So I have x over x plus 4. So my base exponent is equal to argument. This is 5 to the power of minus 2. Now 5 to the power of minus 2, that is 1 over 25. So I have x over x minus 4. This is equal to 1 over 25. Then you cross multiply, you have 25x. This is equal to 1 times x minus 4. So 1 times anything is just equal to that something, so I don't need to put it in brackets. If I was multiplying by anything else except 1, I would put it in brackets. Right, then I collect all my terms with x on one side, everything else without x on the other side. Okay, that's better. Okay, and then I will subtract x. I have 24x, and this is equal to 4. And this means that x is equal to 4 over 24. And this is equal to 1 over 6. So that is my solution. As always, you need to check, see if your answer is correct. log 3 square root of x plus a half. This is equal to 3 log base x of 3. Okay, now to solve this one, what we can first notice is that the bases of the logarithms are not the same. And we've done questions like this before where the bases are not the same. You must change the base to one of the others. And in doing that, we end up with a quadratic equation. So that should already click in your mind that we will have a quadratic equation. Before that, this 3, I can bring it over there. The coefficient of a logarithm becomes the exponent of the argument. And even here, this, I can just rewrite it. Okay, let me leave that one for now. So I have log base 3 square root of x plus half. Okay, let me not even do that. I'm making it more complicated. Okay, so what I'm going to do instead is just change the bases of the logarithm from here, even without multiplying this 3 out. That will just make it more complicated. So what I will do instead is I'm going to change the base of the logarithm to 3. So this is the one whose base I want to make 3. This one already has a base of 3, so I don't need to change that. So I will leave it as log base 3 square root of x, and then the half. Then the half stays as it is. And remember the technique of changing the bases. We said you have one big fraction, then the new logarithm that you want in the numerator and in the denominator, then the argument goes to the top, and then the base goes to the bottom. That's how we change logarithms. Then, just to simplify it, this is log base 3 square root of x plus half. Now this one over here, log base 3 of 3, you remember, is equal to 1, because taking log of anything to that same base is 1. So I have 3 times 1, because this is equal to 1. So this 3 will multiply the 1 over there, and then I'll be left with 3 over log base 3 of x. Now we don't want any denominators, so what we do is we multiply everything with the denominator. So this, I will multiply it here, multiply it there, and I will also multiply it over there. So when I multiply that, what I have is now log base 3, the square root of x, times log base 3 of x plus half log base 3 of x. This is equal to 3. Now here, this square root, now I can rewrite it to the power of half and then bring the exponent down. So I have half log base 3 of x times log base 3 of x plus half log base 3 of x, and this is equal to 3. Now you can see these two are multiplying and they are the same. So that becomes log base 3 of x squared. So this is half, and then I have log base 3 of x squared plus log base 3 of x is equal to 3. Now I will let s equal to log base 3 of x, and then wherever I have log base 3 of x, I will put s instead. So I have half s squared. Yes. Yeah.
Miss, you skip the half there. It's
Yes, the half should
in.
still be there.
Mm.
Okay, thank you. The half should still be there. And then I have half s, and this is equal to 3. Then I want to get rid of the denominator, so I will multiply throughout by 2. So I have s squared plus s and this is equal to 6. Then I want everything on one side, so I have s squared plus s, and this minus 6. This is equal to 0. Then you factorize this, look for two numbers. When you multiply them, the answer is negative 6, and when you add them, the answer is positive 1. So the two numbers are positive 3 and negative 2. So you open your brackets, equal to 0, and you put your s. Then the two numbers, we say, are positive 3 and negative 2. So s plus 3 is equal to 0. This means that s is equal to negative 3. And if s minus 2 is equal to 0, this means that s is equal to 2. Now we solve for s, but in the original equation we had x, so we need to unsubstitute. Remember, s was log base 3 of x. So what I actually have is log base 3 of x. This is equal to negative 3. And also log base 3 of x, this is equal to 2. So this is the first equation, and this is the second one. Now I'm solving the first one. If log base 3 of x is equal to minus 3, this means that x is equal to 1 over 27. So this is my base exponent. So 3 to the power of negative 3 is equal to 1 over 27. And then the second one, so this is my first solution. And then the second one, I have log base 3 of x. This is equal to 2. And this means that x is equal to 9. So I rewrite it in exponential form. 3 to the power of 2 is equal to x. That means x is equal to 9. So those are my two solutions. And again, check. Substitute them into the original equation and see if they both satisfy or if any of them is invalid. Okay, so you need to check, especially with logarithms. Sometimes they satisfy the quadratic equation, but they are invalid in that when you substitute them into your logarithm, you get a math error. Then number 7, we have 3 power of a plus 1 minus 3 to the power of a minus 1. This is equal to 24 square root of 3. Now here you cannot take logarithms on both sides and then split the logarithm, because we do not have a law that works with the sum or difference of arguments. Okay, so what you should do instead is use your laws of exponents and rewrite this as 3 to the power of a times 3 to the power of 1 minus 3 to the power of a times 3 to the power of minus 1, and this is equal to 24 square root of 3. And then you can see 3 to the power of a is a common factor, so you factorize it out. 3 to the power of a, for the first one you'll be left with 3, and then minus 3 to the power of minus 1. Then on the right hand side you have 24 square root of 3. This that you have inside the brackets, you can work it out. 3 minus 3 to the power of minus 1. 3 to the power of minus 1 is just 1 over 3. So I have this 3 to the power of a, and then I have 3 minus 1 over 3. This is 24 square root of 3. So 3 to the power of a, and here what am I left with? I'm left with 8 over 3, because 3 is the same as 9 over 3. Then when I subtract 1 over 3, I'm left with 8 over 3. And this is equal to 24 square root of 3. Then what you do is you multiply by 3 and divide by 8 on both sides. Left with 3a. This 24 square root of 3 times 3, getting rid of this denominator, and then you divide by 8, getting rid of that numerator. So you can see 8 will go there once, it goes there 3 times, then you're left with 3 to the power of a, then this 3 and that one will multiply to give me 9 square root of 3. But 9, you know, is 3 to the power of 2, so I have 3a. This is 3 to the power of 2 times 3 to the power of half. Square root of x means to the power of half. Then bases are the same, so I can combine these two exponents because I am multiplying. So I have 3 to the power of a. This is 3 to the power of 5 over 2. That's 2.5. This means that a is equal to 5 over 2 because my bases are the same, so it means the exponents should also be the same. Are we fine with that one? Okay. Then number 9. We have 9 log x power of 3. This is equal to log base 3 of x. So again here we have logarithms that do not have the same base. So what we need to do is change the base of the logarithm. So I'm going to change this one to base 3. So I have 9 times, I put my big fraction, log base is 3, log the base is 3. Then the argument goes to the numerator, then the base goes to the denominator. And this is log base 3 of x, like that. Then I cross multiply, but remember that this is equal to 1. So I have 9 times 1, which is 9 over log base 3 of x. And this is equal to log base 3 of x. Then now I cross multiply, so I have log base 3 of x squared, and I multiply it there. This is equal to 9. Here I don't need to let it equal to y. You can do that, it's fine, but this is a simple equation because it's something squared. To get rid of the square, I just take plus or minus the square root on both sides. So I have log base 3 of x. This is plus or minus the square root of 9, which is equal to 3. So I will have log base 3 of x, this is equal to 3, or log base 3 of x, this is equal to minus 3. Now from the first one, I have log base 3 of x equal to 3. Here I rewrite it in exponential form. It is base exponent is equal to the argument. So I have 3 to the power of 3. This is equal to x. This means x is equal to 27. That is my first solution. And then the second one, log base 3 of x. This is equal to minus 3. This means 3 to the power of minus 3 is equal to x. Here I have x is equal to 1 over 27. So those are my two solutions that you need to check and make sure that they are both valid and they do actually satisfy the equation. And then number 11. We have 8 over x to the power of 3 minus 1, this is equal to 0. So this one, pretty simple to do. You just cross multiply with the, or you multiply throughout by the x cubed. So I have 8 minus x cubed. This is equal to 0. Therefore, x cubed is equal to 8. I take the cube root on both sides. This means that x is equal to 2. So this one is very simple to do. Nothing difficult there. And as usual, check the solutions. Make sure it does satisfy the equation. Number 13. We have 2 to the power of k plus 2 plus 2 to the power of k minus 1. This is equal to 6 to the power of k minus 1. Okay, so here, excuse me, what you need to do is similar to 7 that we did. We cannot take logarithms because that will not help us with this sum. We will not be able to split the logarithm. So instead what we should do is rewrite it as bases, same bases multiplying, or separate the exponents. In other words, so I have 2 to the power of k times 2 to the power of 2 plus 2 to the power of k times 2 to the power of minus 1. Then I do the same thing on the other side. Now I know that 6, this is equal to 2 times 3. So I have 2 times 3 to the power of k minus 1. Okay, on the left hand side I can factor out 2 to the power of k. So I have 2 to the power of k, then I have 4, it's this 2 squared here, then plus half, which is this one over here. And this is equal to 2 to the power of k minus 1 times 3 to the power of k minus 1. Okay, and then we split the way we always do. This is 2 to the power of k. Now 4 plus half, that is just 9 over 2. I'll write it like this, 9 over 2. And then on the right hand side, I have 2 to the power of k times 2 to the power of minus 1. Then I will say 3 to the power of k times 3 to the power of minus 1. Okay, that's a minus 1. Okay, so let me not split it then. I'll just leave it like that. Okay, then you can see I can divide by 2 to the power of k on both sides. It will cancel. Then I'm left with 9 over 2. This is equal to half. This 2 to the power of minus 1 times 3 to the power of k. Now I split it up, 3 to the power of minus 1. Okay, then first getting rid of this 2 in the denominator, I multiply both sides by 2. So I have 9 is equal to 3 to the power of k times 1 over 3. 1 over 3 is this one over here. 3 to the power of minus 1 is 1 over 3. And then I multiply by the 3 on both sides. So what I have is 3 to the power of k. This is equal to 9 times 3. This is 27. And I rewrite 27 as 3 to the power of 3. So if 3 to the power of k, this is equal to 3 to the power of 3. My bases are the same, so it means that k is equal to 2. Then again, very important, check your solutions. Make sure it satisfies the given equation. Then you'll know if you are right or not. Okay, that was number 12. I don't know why I did an even numbered question. So I was supposed to do number 13, but you can do number 13 and then number 15. Number 15, we have 2 times 3 to the power of 2x. And this is equal to 2 times 3 to the power of x plus 3. Okay, so here we will do the same thing. I can divide both sides by 2. So these 2 will cancel when I divide by 2. Then I have 3 to the power of 2x. This is equal to 3 to the power of x plus 3. Now my bases are the same, so it means that the exponents are also the same. So I have 2x is equal to x plus 3, and collect all the terms with x on one side. So I have 2x minus x. This is equal to 3. Yes. Go ahead.
Hello, miss.
Yeah, you're breaking up a little bit. Yeah, go ahead.
K is supposed to be 3
Excuse
in
me?
the previous question. K is supposed to 3.
K is supposed to be equal to 3. Yes. Here, because it's 3 there. Yes. Okay. And then here what we do, we have x is equal to 3. So what you do, again, check your solutions, make sure it does satisfy the given question. Okay, let's move on to the next one, number 17. With number 17, it says you are allowed to leave your answer to 3 decimal places, so you can use your calculator for number 17 if necessary. Now number 17, we have 2 log of alpha minus 3 minus log of alpha plus 1. This is equal to 1. So here my bases are the same, so I will combine them, but before I combine them, this coefficient over here, I need to make it the exponent of my argument. So what I will have is this. This is log alpha minus 3 squared minus log alpha plus 1. This is equal to a 1 over there. Then from here, the bases are the same. They both have a base of 10. So what I do is I combine them, and because I'm subtracting, then I must divide the arguments. So I have log of alpha minus 3 squared divided by alpha plus 1. This is equal to 1. Then I can rewrite this in exponential form. So the base here is 10. So I have 10 to the power of 1. This is equal to alpha minus 3 squared over alpha plus 1. 10 to the power of 1 is just equal to 10. And then I will multiply the denominator out. So on the other side, so I have 10 alpha plus 1. This is equal to alpha minus 3 squared. And again, let's do our working for alpha minus 3 squared. Now alpha minus 3 squared, this is just alpha minus 3 times alpha minus 3. So multiply out the brackets like that. So I have alpha squared minus 3 alpha minus 3 alpha plus 9. This is alpha minus 6 alpha plus 9. So that is what I will substitute over there. So when I do that, what I get is this. The 10 should also multiply out. So I have 10 alpha plus 10. This is equal to alpha squared. That's a squared. Alpha squared minus 6 alpha plus 9. Then I collect all the terms on one side, 0 on the other side. So I have alpha squared minus 16 alpha, and then minus 1, and this is equal to 0. So here, if it was possible to factorize this, you'd look for two numbers that when you multiply them, the answer is -1, but when you add them, the answer is -16. So you cannot find two such numbers. So what you do instead is you use the quadratic formula, or you can complete the square. It's really up to you. Maybe let's practice completing the square. I hope you remember how to do that. So we have alpha squared minus 16 alpha. We say that this square is incomplete. We need to add something. That's something. We take -16. We divide it by 2, and then we square it. This is just -8 squared, which is 64. So you will add 64. And I know some of you like to add it on both sides. Instead of adding and subtracting, that's also fine. So let me also use that way. So -1, this is equal to 64. So you can see I've added 64 on the left and on the right, so nothing has changed. Then now when you factorize it, this should be alpha. Then you bracket alpha, then this term here, so it's -8, you square. This plus -1 should still be there, and this is equal to 64. And then you add 1 on both sides. You have alpha -8 squared. This is equal to 65. Alpha -8 is equal to plus or minus the square root of 65. And alpha is equal to 8 plus or minus the square root of 65. So there are two solutions over here. So the first one, alpha is equal to 8 plus the square root of 65. The question said to leave our answer to 3 decimal places. This is 16.062. Or the second one, alpha is equal to 8 minus the square root of 65. This is -0.062, also to 3 decimal places. And that is it. So everything we have done previously, completing the square and all of those, make sure you know how to do them. Then number 19. We have log of 4 base t. This is equal to 7. Okay, I see here we will also